Hi everyone, my name is Amitesh and in this video we're going to derive the quadratic formula in 10 minutes. And not only that, we're going to explain the motivation behind it. So let's just dive right into it. So let's talk about quadratic equations, which is what the quadratic formula solves. So we're going to start off with a very nice quadratic equation, which is going to be the following. It's going to be x plus 4 squared is equal to 9. Okay? So why do I say it's very nice? I say it's very nice because the way it's written is going to make it easy to solve. Because what you need to notice here is that something squared is 9. What are the things that square to be 9? Well, the things that square to be 9 are plus or minus the square root of 9. Or in other words, plus or minus 3. Because we can take the square roots on both sides of this equation. So what we can do is we can get that x plus 4 is going to equal to plus or minus the square root of 9, which is equal to the plus or minus 3. And now we can solve for x. So we're going to get x is equal to plus or minus 3 minus 4 by subtracting 4 on both sides. And that's going to be the same as saying that x is equal to plus 3 minus 4, which is going to be negative 1, or x is equal to minus 3 minus 4, which is equal to negative 7. So those are going to be the solutions to our equation over there. Now, why did I do it this way? I want to show you that equations like something squared is equal to something are easy enough to solve when written in that way. And now that observation is going to prove super powerful. Because what we can do is, this actually is a quadratic equation that you can write out in a normal way. And a normal way means the following. What you can do is you can say that x plus 4 squared minus 9 is equal to 0, right? That's the same thing as saying that what we had there. And if you expand out x plus 4 squared using the binomial theorem, the binomial theorem tells you that x plus 4 squared is x squared plus 2 times 4 times x, which is 8x, plus 16, which is 4 squared, minus 9 is equal to 0. So that's the same as saying that x squared plus 8x plus 7 is equal to 0. Now, if I'm given that equation, if you are given that equation, how would you solve it? Well, you try to factor the equation if you didn't know the quadratic formula, or you'd use the quadratic formula. Now, factoring that equation turns out to not be too difficult if you're used to that, but when it's in this form, we can kind of see it quickly. And this is going to be very cool because I'm now going to show you how we can solve this equation even if the 9 isn't a 9, but any other number, okay? So, for example, suppose instead of x plus 4 squared equals to 9, suppose we had that x plus 4 squared is equal to 11. Now, it may be easy enough to factor this equation here as x plus 1 times x plus 7, because we know that the solutions happen to be integers, negative 1 and negative 7, you might be able to see it from inspection. But if x plus 4 squared is equal to 11, the solutions are not going to be integers. Because what happens here is when you write it down this way, you're basically saying that you can take the square root on both sides like we did earlier, and you're going to get that x plus 4 is going to equal to plus or minus the square root of 11, which is not an integer, it's not even a rational number, but now you get that if you subtract 4 on both sides, x is equal to plus or minus the square root of 11 minus 4. So those are going to be the two solutions for x. Another way of writing it is x is equal to root 11 minus 4, or x is equal to negative root 11 minus 4. Now, finding these solutions, if we expand this out as a quadratic, right? So let's try to expand this out in the same way as we did here. What would happen? Well, instead of the 9, every 9 would become 11, right? So x plus 4 squared equals 11. It's going to be x plus 4 squared minus 11 is 0. So the subtracting 9s are all going to be 11. So here we're going to be subtracting 11. So here we're going to get 5. And then we're not going to get this anymore. But factoring this equation here is not going to be easy by inspection. However, we found a cool way of doing it if we knew that it looked like x plus 4 squared equals to 11. And that's going to be the motivation for the fundamental idea of deriving the quadratic formula. So let's kind of see why. Because this formula here works no matter what is on the right hand side, right? This method here, even if it's a 17, a 27, or whatever you like, you can still solve it, okay? So what we're going to observe is that if you have, I'm just going to erase this here, if you have an equation like x plus 4 squared is equal to c, where c is a constant, so I'm going to put the c over here as a constant, then what you can do is you can solve it. You can just say that therefore x plus 4 is going to equal to plus or minus the square root of c. So therefore x is equal to plus or minus the square root of c minus 4. You can solve that equation. But if you wrote that equation down as a quadratic, like you perfectly kind of simplified it out and said x plus 4 squared minus c is 0, well, that's the same as saying x squared plus 8x plus 16 minus c is equal to 0, right? So any quadratic, the c can be any number, right? So here c is a constant, c can be any number, but any quadratic equation, 16 minus c here can also be any number, right? If c is any number, 16 minus c can be any number. So any quadratic equation where you have x squared plus 8x, right? Where you have the 8x, you can actually solve it just by knowing it comes in that form, right? And this is what is the process called completing the square. Okay, so what I mean by that is if I have any equation, like suppose I write this out in red here, suppose I have an equation x squared plus 8x plus 27 is equal to 0, right? How do I solve that equation? Well, I can say that I want 16 minus c to equal to 27, right? So this is just going to be the same as saying that x squared plus 8x plus 16 minus c is equal to 0, where c is equal to 16 minus c is 27, means c is 16 minus 27, which is negative 11. So here c is a negative 11, and that's of course the same as saying that x plus 4 squared is equal to a negative 11, right? So if I got x plus 4 squared equals negative 11, I can now solve for x in this equation, just like I did here, but it's going to be now root of negative 11, so it's going to be an imaginary number, but we can still solve as we can solve a quadratic in this way whenever you have an 8x. But the 8x is not special. What if the 8 was some other number, right? So for example, suppose instead of a 4, I had something like, so let me erase this all out here. Let me say, suppose I had, instead of x plus 4 squared, let me say I had x plus b squared, okay? X plus b squared is equal to c, okay? How do I solve? So I mean here the b looks like a 6, so let me actually write it out in black. X plus b squared is equal to c. I'm going to use capital B here, okay? So x plus capital B squared is equal to c. What does this expand out if we kind of, b is a constant. What does this expand out if we expand it out as a quadratic? Well, it's going to be x squared plus 2bx plus b squared is equal to c. So therefore, x squared plus 2bx plus b squared minus c is going to equal to 0. Now, why is this super cool? Well, it's super cool because b can be anything you like, and we know how to solve this, right? If we have it as the form x plus b squared is equal to c, we just need to take square roots on both sides. So we can just sort of say that x plus b is going to equal to plus or minus the square root of c. So therefore, x is going to equal to plus or minus the square root of c minus b, right? But if you see it in this form, it may not be so easy to solve it just by inspection, but we could do it when we saw it in that form. And here, if b is anything, you can change the coefficient of x, right? Any coefficient of x is possible because you're taking 2 times big B. So here we had, when big B was 4, in our example, we had a coefficient of 8 times x. If big B is 3, we have a coefficient of 6 times x, okay? So I'm going to finalize by giving you one more example and ask you to kind of write it in this form as an exercise, and then we're going to solve. So let's kind of do that. So I'm going to erase this all off here. So let's erase this and kind of write it out here. So I'm going to give you the equation. Let's say instead of having x squared plus 8x, let's say you have the following. Let's say we have x squared plus, let's say, 18x minus 13 is equal to 0, okay? How are you going to solve this equation? So my hint is find out what b and c should be to get it in this form which we can solve. How are you going to do that? What is big B and what is C going to be? I want you to pause the video and then we'll figure it out. Okay, pause the video, work it out yourself, drop me a comment down below, and don't forget to like and subscribe. It means so much to me that you watch this far. But liking and subscribing, you're going to help me create lots and lots of free, infinite, accessible math education. Okay, so assuming you pause the video, let's kind of get into this. So what should B and C be? So my hint is first figure out what big B should be. Okay, to get the right coefficient of x, then you can figure out what C should be. So here we want 2 times big B is 18. So therefore, we want big B to be equal to 9. Okay, so then we're going to get when we take x plus 9 squared, right, we now want to subtract a c to get x squared plus 18x minus 13 is 0, but we can sort of do this. X plus 9 squared minus c is 0. Well, that's the same as saying that x squared plus 18x, so plus 9 squared, which is 81, minus c is equal to 0, right? So if we want our equation, I want our coefficient to be minus 13 or 81 minus c. I mean, you could have done it this way too, 81 minus c. Well, you want 81 minus c to be equal to negative 13. Okay, so we want it to equal to negative 13. So therefore, you want that c is going to equal to 94. Okay, so c is going to be 94, and therefore our equation is going to be, our equation x squared plus 18x minus 13 is 0, is just going to be x plus 9 squared minus 94 is equal to 0, which is the same as saying that x plus 9 squared is equal to 94. Okay, and now you can solve this for x. Okay, I'm not going to do it, but I leave that as an exercise, and drop me a comment down below. What do you think x should be? How do you write out the solutions? But with this idea, you see that any quadratic equation whatsoever can be written in this form. If you sort of have the x squared, you can manipulate, you can choose a b and a c so that you get any other coefficients here and here. Okay, and that's the key observation to solving the quadratic formula. That's what we're going to do right now. I'm going to show you the proof now, and I want you to think about how it relates to what we all did. But let's dive into the proof. Okay, so I'm going to erase this all off now. And I know the video has gone a little bit over 10 minutes, but let's try to it's going to be wrapped up pretty soon. I basically showed you how to derive it already. But now we're just going to finalize it. And this is how people think in math. You know, this is a key idea to understand equations in this form. X plus something squared minus something else or plus something else is 0. Then you can solve it easy by taking square roots. And then you sort of see any quadratic equation can be written in that way. Okay, so that's the kind of key insight that's needed. It's not obvious by a long shot. Even though it looks obvious in hindsight, it's quite a deep observation, leads to the quadratic formula. But let's kind of now get into it. So suppose we have an equation like ax squared plus bx plus c is equal to 0. How do we solve the equation? So the first thing we're going to do is we're just going to divide the equation through by a. Just get it with an x squared. You know, like get the coefficient of x squared to be 1. So let's just do that. So here we're going to divide by a. So we're going to get x squared plus b over ax plus c over a is equal to 0. Now what we're going to do is we want to do this process which is known as completing the square. We want to write this equation as x plus something squared plus something or minus something is going to equal to 0. So we want, you know, if we want to say x plus something, let's say x plus big B squared minus big C, right? We want to write it, or x plus big B squared, let's say plus big C. Okay, we want to write it in this way. Well, x plus big B squared plus big C is going to be equal to x squared plus 2 times big B times x plus b squared plus c. Okay, is equal to 0. And here what we can do, so I'm going to remove the equals to 0 for now, but here what we can do is we want the 2 times big B to match up with the b over a, which is easy enough. That's going to tell us that big B is going to equal to b over 2a. And similarly, we want the b squared plus c to match up with c over a. So now we know that big B is going to be b over 2a. We can work out what big C should be, okay, to complete the square. So big C should be equal to c over a minus big B squared, which is going to equal to c over a minus b squared over 4a squared, okay, which is going to equal to 4ac minus b squared over 4a squared. By making a common denominator, we're going to get 4ac minus b squared over 4a squared. You're kind of seeing the quadratic formula coming in now, and this is going to be super cool. So now we know what is the solution to this equation, x plus big B squared minus big C. So I've introduced these new letters. What is that solution going to be? So here we're going to just erase this all off, and we're going to get the following, which is going to be super cool. So we're going to get x plus big B squared plus c. Okay, so x plus big B squared plus c is 0 is the same as saying, it's the same as saying that x plus big B squared is equal to negative big C, which is the same as saying that x plus big B is equal to plus or minus the root of negative c, right? Plus or minus the root of negative c, and therefore x is going to equal to plus or minus the root of negative c minus big B. But now we can plug in, so we know negative c, we know c is 4ac minus b squared over 4a squared. So what's the root of c going to be, right? What is the root of negative c going to be? So we can sort of write this out here. I'm going to do this here. Negative c, or root negative c, is going to equal to the square root of 4 of b squared. Sorry, I'm going to just erase that here. It's going to be the square root of b squared minus 4ac divided by 4a squared. And the square root of 4a squared is just 2a, right? Because 2a times 2a is 4a squared. So this is just going to equal to the root of, I'm just going to put this here, root of negative c is going to be square root of b squared minus 4ac by 2a. Okay, so we're going to get x is equal to plus or minus the square root of b squared minus 4ac by 2a minus big B. So what is big B going to be? Big B is going to be b over 2a. So it's minus b over 2a, which is therefore equal to minus b plus or minus the root of b squared minus 4ac divided by 2a, and that is the quadratic formula. All done. It took me 14 minutes, but that's the formula, and I showed you the motivation and also how we can derive the formula just by understanding the completing the square process. So you can, even without applying the formula, you can actually go through this process of what is called completing the square and derive the solution to any equation, which is what we did in the beginning of this video, or you could just apply the formula or derive it in general. So thank you so much for watching. I hope you loved that video. Please like and subscribe. It means a lot to me. I'm trying to create free accessible math education worldwide, show people how the math actually works, take you on a journey, show how we think, how we motivate stuff, not just present formulas or present proofs. You know, really make it fun, accessible, and so you deeply understand it. So thank you so much for watching. I'm super excited to see you in the video. Next video, like and subscribe, drop me a comment down below. I'm super excited to engage with you. Wish you all the best, and I will see you soon.